Hey class, welcome to day one of AP Calculus BC. Obviously this learning arrangement isn't ideal, but we're going to make it work. So first thing I want to talk about is the difference between what you learned last year, which was called AP Calculus AB, and what you're taking now, which is AP Calculus BC. So all of this comes from the College Board. This first one says AP Calculus BC is an extension of AP Calculus AB. The difference between them is scope, not difficulty level. So how much it covers, not how hard the material is. AP Calculus AB includes techniques and applications of the derivative. This is stuff you did last year. The definite integral, fundamental theorem of calculus, and it's equivalent to 1 semester of calculus. So all that's what you did last year. What we'll do this year, BC, includes all of the topics in AB. So half of your AP exam will be things you learned last year, plus others such as parametric, polar, and vector functions and series. It's equivalent to an entire year of calculus. They'll go on to say that topics include the following. What's on the AP Calculus BC exam? It includes lots, including, so all the topics from the AB exam, what we did last year, plus vectors, parametric functions, polar functions, polar graphs using derivatives, parametric functions, Euler's method, improper integrals, integration by parts. If you kind of glance through this real quick, certain words happen over and over and over again. Let's see if we can find them here. There's the highlighter. There it is. So we've got parametric, vector, polar, parametric, parametric functions, polar curves, parametric curves, sequences and series. Yeah, all this stuff, the basics of this, you didn't learn how to do derivatives of vectors or derivatives of parametric functions or derivatives of polar functions, but you learned about all this stuff that I highlighted in what class? In pre-calculus. Or at least you were supposed to. So in pre-calculus, you kind of learned the basics of this stuff. Now, obviously, you didn't use any of that last year. So this entire first unit, Unit 1, is titled Things That I Should Have Learned in Honors Pre-Calculus. Yeah, but maybe you didn't. So all this stuff from Honors Pre-Calculus, not everything from Honors Pre-Calculus, but the things that you needed to know, or that you will need to know from Honors Pre-Calculus that you'll need this year. So the first one, notice parametric equations popped up a lot. So the first couple days, today we're going to talk about parametric equations, and then later this week we'll move into polar equations. Again, we're not doing any calculus yet. We're just going to review what you should have learned a couple years ago. So example 1, asks us to graph parametric equations. So parametric equations are the ones, they look like this, where it gives us a third variable t, and it defines the x value and the y value in terms of t. So the x value is equal to t plus 1, whereas the y value is equal to t squared minus 2t. T usually indicating time. To graph, we are going to set up a chart, but instead of just x and y, now we're going to start with t, and we're going to get x values and y values. So if I plug in 0 for time, at time 0, the x value, so the particle, has an x coordinate of 1, and a y coordinate, if I plug in 0, I get 0. Plugging in 1 for t gives me an x value of 2, and a y value of 1 minus 2. Plug in 2 for time gives me 3, and 2 squared, 4 minus 4. Plug in 3 for time. Gives us 4 for x. And 9 minus 6. And plug in 4. Plugging in 4 gives us 5 for x. And 16 minus 8. So when we're graphing it, we're going to plot the xy values. So we have the point 1, 0. We have the point 2, negative 1. We have the point 3, 0. We have 4, 3. 1, 2, 3, 4. And we have the point 5, 8. And you will notice this set of parametric equations forms part of a parabola. If we start with t is greater than or equal to 0, we just get this part. If we plugged in some negative values for time, we'll get the rest of the parabola. So if I plugged in negative 1, now I'm getting 0 and 1 plus 2. So 0, 3 is another point on that. And if I plug in negative 2, I'm going to get negative 1, 8. And notice we could get the entire parabola. It's okay if you just list the ones starting at t equals 0 on. Usually also we indicate the direction. So as time increases, so it goes from negative 2 to negative 1, negative 2 we were here, negative 1, 0, 1, 2, 3, 4. We throw a couple arrows on there to show that as time goes on, the particle moves in that direction. Example 2, so the next few examples here, we're going to be switching back and forth between parametric form, which is what this is, and rectangular form. Rectangular form is y equals something in terms of x. So we're going to have y equals something maybe like 3x squared or 2 sine x, but x and y are the only two variables for rectangular form. Parametric form, now we have the parameter is this t. So we are given x is equal to t plus 1 and y is equal to t squared minus 2t. In order to eliminate the variable and change from what was parametric form into polar form, or not polar, rectangular form, we want to solve one of these equations for t. The easier one to solve is by far going to be this one. So that equation right now says x equals t plus 1. So t is equal to x minus 1. And then we can substitute that into the other equation. So I'm going to replace t with x minus 1. And from there we can expand. So x minus 1 squared is x squared minus 2x plus 1. Distribute. And final answer in rectangular form is y equals x squared minus 4x plus 3. Notice if I graph y equals x squared minus 4x plus 3, maybe. I should get the same points that I got when I graphed it by hand, because that's the same parametric equation that we just graphed. What in the world? Try it again. Y equals x squared minus 4x plus 3. Looking at the graph, we get a parabola that opens up. It looks like it's about the same points. We could look at the table and we could verify those are the same points that we were getting when we graphed it by hand. 0, 3. 0, 3 is on there. 1, 0, 2, negative 1, 3, 0, 4, 3, 5, 8, and so on. Example 3. Eliminate the parameter and write the rectangular equation in standard form. So again, you want to choose which one to solve for. It doesn't matter which one you choose. Again, I think this one, x equals root 2, is a little easier to solve. Or root t, not root 2. So t is equal to x squared. If we substitute that in, we get y equals the square root of 9 minus x squared. Which is okay. This technically isn't standard form. Because I have an x squared and I technically have a y squared, if I square both sides, it would look like this. If x and y are both squared, we usually write them on the same side. I'm going to add x squared over. Anybody know what that equation is, what it looks like? Should be a circle with a center at 0, 0, and a radius of 3. You can actually graph on your graphing calculators from polar or parametric form. You can't do calculus on it, but you can graph. In order to do that, you go to mode and change from function to parametric. And now when you go to y equals, it gives you not only an x, or not only a y equals, but an x equals as well. So I want to graph x equals square root of t. T is the same button as x when you're in function mode. So t is right here. And then the y equals here, we're going square root of 9 minus t. And it doesn't draw a great graph. Actually, that's a pretty terrible graph. I think we need to change our window. Notice it's starting with t equals 0 and right now going up to looks like 2 pi. So I'm going to change that. We're going to start at -10 and go up to +10. Hopefully that'll help. Maybe not. Well, we're getting part of a circle at least. I'm not sure why it's not drawing the whole thing. I'll take a look at that, get back to you. Moving on. Example 4. Again, asks us to eliminate the parameter. This time it asks us to also identify the conic section. I wouldn't worry too much about that. And our equations are x equals 8 cosine theta and y equals 4 sine theta. When this is the case, when we've got sines and cosines in there, we are not going to solve for theta. We are not going to use like theta equals arc cosine of x over 8 and try to substitute that in here. That's going to be a mess. Instead, what we're going to do is we are going to, so we've got x equals 8 cosine theta, divide both sides by 8. And we also have y equals 4 sine theta. Let's get sine by itself, divide both sides by 4. And then what we want to do is we want to use the trig identity cosine squared theta plus sine squared theta is equal to 1. Hopefully that's something you remember. So I can get cosine squared theta by squaring both sides. So we get x squared over 64 equals cosine squared theta. Square both sides here, I get y squared over 16 equals sine squared theta. And now I can substitute this into our identity. So we've got x squared over 64 plus y squared over 16 equals 1. And maybe if you remember a little bit about conic sections, you'll recognize that this is and ellipse. Should be an ellipse. Center is at 0, 0. Major axis is 8. Minor axis is 4. Don't worry too much about that. You try this one. Go ahead, pause the video. You try this. Once you think you've got it, push play. We'll check to see if we're right. Notice x is already squared, so we don't need to worry too much about that. We'll divide both sides by 5. So x over 5 is equal to cosine squared theta. Here we get y over 2 equals sine theta. So y squared over 4 is equal to sine squared theta. Cosine squared plus sine squared is equal to 1. And we have eliminated the parameter. We got rid of the thetas. We've got an equation in rectangular form. Notice here that y is squared, but the x is not. Therefore, it is a parabola. It should open sideways, either left or right. Example 6. Asks us to find the set of parametric equations using. So this time they're giving it to us in rectangular form, and they want the parametric equations. If they're going to do that, they need to give you some relationship. So we're going to do this twice. The first time, they want us to make t equal to x. So our first equation is given to us here. X is equal to t. To get the second equation, this one's easy enough. I just need to replace the x's here with t's. So y is equal to 4 plus 2t minus t squared. And now we have two equations. One with x equals, one with y equals. Part B is a little bit more difficult. They give us t equals 9 minus x. So to get the x equation, we need to solve this for x. So if I add x to both sides and subtract t, it's going to say x equals 9 minus t. So there's the x equals equation. To get the y equals equation, again, we're going to go to y equals, but we're going to substitute 9 minus t in for the x's this time. So it's going to say y equals 4 plus 2 times x. X is 9 minus t minus x squared. And then it's just a simplifying game. Distribute your 2. Square this. Uh-oh. Distribute your minus sign. And combine like terms. So y equals negative t squared plus 16t minus whatever that is. 59, I think. One more type of problem. And again, we are looking for the parametric equations. And this time they give us a conic section in this big, long, ridiculous form. 25x squared plus 9y squared minus 100x plus 54y minus 44 equals 0. In order to do this, we are going to need to change from this big long standard form to what is called center form. You did it in Algebra 2. I believe you did it again in pre-calculus. So we need to group the x's together. So we've got 25x squared minus 100x. We're going to leave a little space here. We're going to group the y's together. And any constant, in this case minus 44, I'm going to add 44 to both sides. We want to write this as something squared, so we're going to need to complete the square. But before you do that, to complete the square, a has to be 1. So we first want to factor out the 25. Factor out the 9. Now we can complete the square. To complete the square, we need to take the b value, divide by 2, gives us -2, and then square it. 4. And if you did it right, you should be able to write this as something squared. Numbers that multiply to 4 and add up to -4, -2 times -2, -2 plus -2. When I wrote down +4 right here, I did not add 4 to this left side, because if I distribute this, it's really 25 times 4. So when I wrote down +4, I actually added 100 to this side. So I need to add 100 over here. Do the same thing with the y's. 6 divided by 2 is 3. Squared is 9. Bring this 25 down. Bring this 9 down. Again, if you did this right, you should be able to write this as something squared. It should be y plus 3. I wrote down +9, but I really added 81 to the left side. Add 81 to the right side. Combine these up. I believe we get 225. And then divide both sides by 225. Divide by whatever this is over here. (25) divided by 225 reduces to 1/9. 9 divided by 225 reduces to 1/25. So we have changed this ellipse from its big, long, standard form. We've changed it to center form. It's an ellipse. Its center is at 2, -3. We're going to go left and right 3 units to get the covertices, and up and down 5 units to get the vertices if you had to graph it. Problem is, that's not what it asked for. It wants us to find the parametric equations. And we can do that by, again, using our trig identity. Cosine squared plus sine squared equals 1. And I have this plus that equals 1. So this right here is equal to cosine squared. So I can set x minus 2 squared over 9 is cosine squared theta. And this part right here is equal to sine squared theta. And then solve for x and solve for y. So if I take the square root of both sides, I get x minus 2 over 3 equals cosine theta times 3. Add 2. This one's square root. Times 5. subtract 3. So that is it for the notes here in section 1. If you're having questions, please reach out. Let me know.